Hey, what's up guys? This is Creative Creator here. So today in this video, I'm going to review the WS2811 addressable RGB LEDs, and also I am going to discuss how you can control these LEDs with Arduino IDE. So with that being said, leave a like and subscribe to this channel, and let's jump into the video. Okay guys, so let's talk about the LEDs. Here I am using 12mm addressable RGB LEDs, which has a control board inside in it. The name WS2811 stands for the WS2811 IC. The IC takes the data signal and produces different colors for the LEDs. The same thing applies for the WS2812 LEDs also. If you see the LED strips carefully, then you will find that there is a male port and there is a female port. The male port is used for sending the data signal to the LEDs, and the female port is used for sending the data signal to the next LED strip. Let's talk about how you can run these LED strips. In this case, there are many options to choose from, like T1000S, AC008, SP108E, and much more. The main key feature of these controllers is that you will get a software interface for making different patterns, and no coding knowledge will be needed for running these LEDs. And hey, if you have innovative imagination, then you can make some pretty dope patterns. By the way, if you want to buy these controllers, then I have given the best purchasing links in the description box below, so you can check that out. Those are the pros of these controllers. Now let's talk about the limitations of these controllers. These controllers can only handle a certain numbers of LEDs. Suppose we are talking about T1000S, it has a limitation of 2048 LEDs, so we can't connect more than that. So it is the only limitation I found about these controllers. Anything other than that is pretty fine if you don't want to mess with the coding stuff. Now let's talk about how we can use our Arduino IDE. In this case, I am using Arduino Uno R3 as a controller. Now let's take the digital pin 5 as the data output. So we need to connect the Arduino pin 5 with the data in pin of the LED. Now we need to connect the Arduino's ground pin with the ground of the LED strip for making the circuit complete. Next, we need to give the power to the LEDs. In my case, I am using a power bank. You can also use any 5V power supply as you wish. Next, we will dive into the software section. First, open your Arduino IDE and then connect the Arduino with the USB port. At next, head over to Tools and then go to Board option and then select Arduino Uno/Genuino Uno. Okay, so then go to the port option and then select the right COM port. Now I will show you two ways for running these LEDs. Everything should be as simple as possible. You will need two libraries. One is Fast LED and another is Adafruit NeoPixel. If you don't have these library files, then I have given links in the description box below, or you can go to Sketch, then go to Include Library, and then click on the Manage Library option, and then search for your library and then install them. It is a simple one. And then go to Files and then go to Example, and then you will find Fast LED. Okay, so now you can see many examples are there. From there you can choose anything, so I am just choosing the color palette. Now you can see it is an example code from Fast LED. You will need three main parameters: LED pin, number of LEDs, and brightness. The LED pin defines the data pin from which we will get the data signal for the LEDs. The num LED defines the number of LEDs. Here I will connect two sets of LEDs 50 each, so it means that total will be 100 LEDs. So I will change the number to 100. Now the brightness. You can use any values from 0 to 255, where 0 is for 0% brightness and 255 is for 100% brightness. So I have changed the brightness to 250, which I think above 90%. Now let's compile it first. Now let's upload it to Arduino. Now you can see that it is showing done uploading, so it means that the code is uploaded. Now you can check the LEDs. Okay, in same way I am opening standard text example from Adafruit NeoPixel. Now you can see the code, and I hope you will understand everything and what parameters you should have to change. Now I have changed the LED pin and the LED count, and then go below and then set the brightness to 250 as the same thing we have done before. Now let's compile it first and then upload it to Arduino. Now you can see the LED strip lights up. So what do you think what will happen if you connect one more LED strip with it? So let's see. Here you can see I have connected one more LED strip with it, but you can see nothing changed. Extra LEDs are not glowing. As you know, we have selected 100 LEDs in the coding, so it means that the signal will go into the first 100 LEDs, so it will only run the first 100 LEDs, not the backwards one. Okay, so hope you understand. Keeping all these things in my mind, I have made these schematics. Then I converted the schematics to PCB and ordered it from jlcpcb.com. They are one of the largest PCB manufacturers in China. Just upload your Gerber file today and get your first 10 PCBs only for $2. They don't take extra charges for PCB color. Processing time is 48 hours and shipping time is also very quick. And you can see the PCB quality. It is just great, and I have only paid $2. Now for the component section, I have gone with lcsc.com. They are one of the leading electronic component distributor in China. LCSC provides different type of things such as resistors, capacitors, ICs, modules, RF transistors and much more. And for this project, I have ordered some components from their website. Currently, they are offering $4 off on your first order. But hold on, if you order through my link, you will get exclusive $8 off on your first order. So why you are waiting for? Place your first order from lcsc.com. Then I gathered all the components and soldered it on the PCB. Then I uploaded the code into the Arduino Uno and then removed the 328p chip and fixed it on the PCB. Now the PCB is ready to use. Now I connected the PCB with the LED strip and give the power, and next the LEDs turned on like a charm. Let's talk about the current consumption of the LED strips. Every LED has a red, green and blue LED diode inside in it. Each diode can take maximum up to 20 milliamperes of current. So 3 diodes take about 60 milliamperes of current. Now each strip has 60 LEDs, so in total there will be about 60 cross 50 milliampere, so it is about 3000 milliampere or 3 amperes of current. But in practical usage, I have connected 8 chains in parallel with its full brightness. Now guess what? The amperes which was taking from the power supply was about only 4 amps for 8 chains. One thing you should note that WS2811 LEDs runs on DC 5 volt, You all know that DC has some great losses, so you should use high gauge wires, otherwise you will see that the first LED near the power supply will glow higher and last LED will glow lower. In my case, I have given power each and every LED strip individually. Okay guys, so that is all I have learned from working with this type of LEDs. Hope you guys like my take on WS2811 addressable RGB LEDs. Okay guys, so that is pretty much enough for this video. I hope you have a great day. Thank you so much for watching, and this is Creative Creator signing out. Hope to see you guys in my next video. Peace out.